Hello and welcome everybody to another episode of the live coding series. I hope you're all doing well. Thanks for joining in today, everybody. Today we've got some really exciting content lined up. We're going to be talking about Google's DeepDream technique and how you can actually use it on an iOS app, but we're not going to be doing the computation locally. We're actually going to be having the iOS app send images to a server that we're going to build today. That server is going to actually do the DeepDream processing, send that art back to iOS for it to be shown on screen. It's going to be really fun. You can actually follow along with us during today's episode. If you'd like to code this in yourself, you can implement your own iOS app, you can implement your own backend, and actually follow along and implement this application. Today, I'm joined by two incredible coders. They are really passionate about what they do, and it's really exciting to be able to do a live coding episode with the both of them. Their names are Omer Kamal and Labeeb Zaker. And so welcome to Omer and Labeeb. Omer, would you like to start by introducing yourself?
My name is Omer Kamal. I'm a software developer at IBM.
And Labeeb?
Hello, I'm Omer Kamal Zaker, and I'm a third year mechatronics engineering co-op student at McMaster University.
Wonderful. Thanks for joining in today. And let's actually get started with discussing a little bit about the architecture of the application we're going to build today. So here's the idea, everybody. What we're going to do is, as I mentioned, we're going to build an iOS application first of all. And the iOS application, what it's going to do is it's going to have an image picker that enables you to choose an image from your photo library. And then once you've chosen an image, it's going to take that image, send it over to a Flask server that Omer and Labeeb are going to set up for us. That Flask server is going to send that image to a little bit of code for this thing called DeepDream, and we'll talk about what that is in just a moment. And then after we've generated a DeepDream image, the Flask endpoint is actually going to return that image as a response to the request sent by the iOS app, and then the iOS app can display that image on screen. So, Omer, anything to add to that in terms of how exactly we're going to structure the app?
No, we're probably gonna have a hard time since you doing your iOS app on your laptop and doing the backend on my laptop to do the communication. But other than that, everything should be fine.
All right, sounds good. Now, if you don't want to actually port forward on your on your router, we can use something like ngrok, which is an amazing tool, by the way, that enables you to bypass firewalls and sort of proxy into different servers. But let's go ahead and start. Okay, so I'm going to show everybody my screen for a moment. As you can see, we've already got a couple of things set up. You can see my phone over here. I'm actually able to control. You can see that on my desktop. And actually, what I feel like would be helpful is if I would just quickly share my desktop. Okay, now everybody can actually see my screen, and you can see the three of us as well in the corner. So as you can see, we have my phone over here. And I'm able to control that, and you can see what's happening on my Mac. I've also got my terminal open. There's going to be a few other things that we're going to use today. One of them is going to be Xcode, of course. So I feel like I'm going to dive right into the iOS app. Labeeb, Omer, the two of you can get started with your backend, and we will reconvene soon as you work on that. Does that sound good?
Yeah, that sounds fine.
Great. So something that I just wanted to quickly talk about in terms of the DeepDream mechanism and the technique and how it works is DeepDream works in a really special way. So the way DeepDream works is what you're essentially doing is you're taking a convolutional neural network that traditionally consists of an input, multiple convolutional layers, and then an output. And you're stripping away the last few layers of the network entirely, right? No retraining, nothing. You're just stripping away those layers. And you might wonder, what's the point of stripping away layers? Well, remember, with a convolutional neural network, different layers will activate at different portions, right? Different filters will activate based off of patterns that they identify. So, for example, if you're looking for a dog, then maybe you would identify the nose or the ears or the eyes or something, and the convolutional filters would activate certain filters will activate when they see something that they've been trained to respond to. And what we want to do is we want to exploit that, as well as a little bit of calculus that we luckily don't need to implement ourselves because of TensorFlow, in order to generate art. The way it's going to work is we're going to, as I mentioned, strip away those last few layers of the network, And we are going to add actually another layer to the network. And that other layer, all it's going to do is it's going to take the last layer and all of the values, we're going to run a mean operation. So we're going to get the average value across all filters, across all pixels. And then what we want to do is we want to run something called gradient ascent to increase that value as much as possible. But we can only change the input image. Okay, so we can't change the weights. The weights are locked. The network weights are exactly what they were. But we can change the actual image that we fed into the network. So we're sort of flipping gradient descent on its head. Gradient descent usually means the inputs are locked and the weights are unlocked for you to change. With this technique, we're doing gradient ascent, so we want to increase the mean value, and at the same time, we want to change the input image, but we don't want to change the weights. The effect that this has is that we end up generating like psychedelic art in a way using gradient descent. And so let's dive right into it, I would say. And to begin today, we're going to have to start off by developing the actual iOS application, which the plan for this iOS app is to build it by using the SwiftUI tooling. And SwiftUI is great, but not everything can be done in SwiftUI today, unfortunately. There are a couple of things that are still sort of holdovers from the UIKit era, including image pickers, which are notoriously weirdly difficult to implement in SwiftUI. But regardless, that's exactly the challenge we're here to solve today. So let's get started. I'm going to open up my Xcode. Give that a second. Sometimes macOS Big Sur doesn't like being particularly fluid.
Are you on Big Sur or are you on macOS? Like the regular one?
I'm on the beta Big Sur.
Maybe we shouldn't be doing this on the beta.
You're absolutely right. We shouldn't. Never install a beta software on a daily driver device. But the issue is that my phone is iOS 14, and the iOS 14 SDK only exists on the macOS beta. So if I wanted to run this on my stable partition, I wouldn't be able to, because then I wouldn't be able to push the code from my stable Mac to beta iOS. But still, let's get started. So I'm going to create a new Xcode project for this, and we'll just call it
Okay, so before we get started, let's break down to what me and Libby will be doing.
Sure.
So I'll be implementing the TensorFlow component, and Libby will be doing the request sent. So how the communication is going to work.
Sure.
So a REST endpoint basically is what we need.
Sounds good.
Great. Okay, I see somebody in the comments saying ngrok is a very insecure tool. It's not a good tool, and you're absolutely right. It's terrible from a cybersecurity standpoint. You know, folks that I've worked with on cybersecurity teams despise ngrok because it can be used in some pretty bad ways. However, I will say that there are a couple of use cases where ngrok is a lifesaver, and this happens to be one of them. So, as long as you're using it the right way, it's fine. All right, so let's go ahead and create the new DeepDream application. So what we're going to do is we're going to use the brand new cutting edge iOS 14, or technically SwiftUI 2.0 features. So we're going to be using the SwiftUI app lifecycle instead of a UIKit app delegate. And let's just dive right into it. So I'm going to store this project on my desktop. Also, I do see a couple of questions. So if you have any questions about the code that we're writing right now, feel free to send them in and we'll answer them right now. But Tassin, I do see your question about machine learning and healthcare. We'll be answering that and other sort of broader questions towards the end of today's episode. For now, we're going to be working on the implementation. All right, so as you can see, we've got a SwiftUI application open, which laggily will render into a full screen. And let's go ahead and actually implement the image picker. Now, the image picker, to begin with, will need to be something that we bridge in from UIKit. And the way you bridge in UIKit code is by using these things called hosting controllers in SwiftUI. So let's go ahead and take a look at how we can implement a hosting controller for an image picker. So just give this a second. UI kit. Image picker Swift UI. All right. Okay, so let's take a look at the first result. Now, in theory, making one of these views shouldn't be all that difficult, but it requires an understanding of a few different UI kit and Swift UI bridging elements that I haven't fully looked into just yet. Also, yes, I do see a question. Can I do it side by side? I'm on Catalina 10.15.6. You can absolutely do this on Catalina because we're not using any iOS 14 specific features. We're not using like those like for example the Swift UI lifecycle. I'm not really leveraging any of its components. I'm just using it. You could just as easily do the same thing with a UIKit app delegate lifecycle, which you do get by default on Catalina, of course. And is very easily accessible. So yeah, you won't see any noticeable code differences between the two. And yes, I will make it bigger. All right, so the image picker structure looks relatively simple. I'm just going to copy that into the same file that I'm coding my content view in for now, and then later we'll make it a bit cleaner by moving it to a separate file. And of course, we also need a coordinator view. And we need to change make UI view controller, I think. Yeah, we gotta give it a coordinator. And also give it the ability to create a coordinator. So basically, what this code should do is it should create something called an image picker structure, which is a UI view controller representable. What that means is that it's technically a UI view controller, but we're wrapping in another protocol that enables Swift to actually use the UI kit view within Swift UI as a Swift UI view. The way it works is by having this thing internally called a coordinator. And traditionally, when you would implement like a UI kit view controller, you would actually have your view controller itself conform to things like UI image picker controller delegate. But in this case, the image picker cannot conform to that because it's a structure, not a class. So you create a separate class within the structure called coordinator, which is a UI image picker controller delegate. And then through that, you can actually have the structure create its own coordinator, and then from that coordinator, you can use it to catch the functions that the image picker will call. So that's how that works. Now let's see how we can actually use this in our code. So of course we would need to make this really conform to UI image picker controller delegate if we want it to do anything. And the way we can do that is by implementing image picker controller did finish picking media with info, and passing the image back to the parent, which is the image picker structure, and then telling the parent to dismiss itself from the view. So that should solve a lot of problems at once, actually. And if I just go ahead and make this a bit bigger for everybody to see, that's what we're doing. Okay, now we will need to implement a little bit of code that will have a button that enables us to pick an image, and then after we pick the image, display that image until we have the DeepDreamed version of that image. So for that, let's create a state variable called image, and let's just make this for now a UI image. We might make this an actual image view later if we want to, but for now we'll keep it a UI image. And I see another question: wouldn't Flutter be better for machine learning apps than Swift? And this is something that I've talked about before. My belief is that applications should always be native, right? It takes a lot more effort and it's a lot more engineering that goes into it, but it's always worth it to make applications native. Now, I do know that Flutter is way better than previous attempts at, cross-platform native applications. You have control down to the pixel level. But the thing is, the experience that you get when you build a truly native application is just really unmatched, especially when you have access to libraries like CoreML and CreateML through Swift that you wouldn't get access to through Flutter. You have access to the wonderful Swift UI API, which really is, I would say, state of the art in terms of being able to build user interfaces. So building native is always better.
Yeah, cross-platform is not the best, especially when it came to gaming console. The PS3 versus the Xbox 360, it was not even comparable. But even through the PS3, like later in the year, it got like some amazing games and graphics.
Well, I wouldn't know too much about that, but
It was before your time.
was it? Okay. When was it released?
I think it'll probably be like 7 or 8.
That's a long time ago.
Yeah, you were like a little kid.
Was that like 9 years ago?
Let me double check when the PS3 came out.
You're on 7.
7 years?
I think 7. I'm pretty sure.
Yeah, it was 2016. I mean, sorry, 2006. And when it first got released.
Interesting. Okay, so we're going to need another state variable called showing image picker. And this is just a boolean that determines whether or not we are currently showing an image picker, which by default, of course, is false. And then we can just create like a little button, and this button will have an action and a label. The action, we're going to fill this up later, but in terms of the label, we could do just like pick an image. At which point we would also have a sheet that would be shown under some circumstances, specifically if we are showing image picker. When we dismiss, then we need to run some kind of action, which in this case will be to load the image. Which, how exactly would we do that? Okay, so we will pass a binding to a binding of the optional image to the image picker, like so, and that should create a valid view. So this should technically build. Great, so it builds. So we have a button as well as a sheet that, when showing image picker is true, will show an image picker, passes it a binding to the image that we have stored within the structure, which is a state variable, and then we'll go ahead and show that. Now, of course, we don't always want to show the button. Under some circumstances, we would want to remove that. So let's just put this inside of a Z stack, and let's hide it, but only if the image is not nil. So for that to happen, we would need to do if image is nil, then show it, otherwise no need to. Now when you click the button, all we need to do is showing image picker equals true. And the rest will happen magically thanks to Swift UI. Now if the image is not nil, then we of course want to show the image. So at that point we can just do, we can show image and then pass it a UI image, which would be the one within the structure. Just so you know, there would be a couple of other changes if you're doing this on Catalina, Ganesh, and that is, one of the changes would be, like, for example, in the new Swift 5.3, I believe the release is, over here, like, when you're accessing this image property of the structure, usually in other versions of Swift, you would need to do self.image to explicitly say that you're capturing self within a closure that escapes. But in this case, you don't need to, because Swift UI is granted an exemption for that by Swift, just because they don't want you to have to write self everywhere. So there will be a couple of minor changes if you're doing this on a different operating system version, but overall the idea is the same. Okay, so that should pretty much be it for actually choosing an image. How about we go ahead and test this out? So to actually test this out, how about I go ahead and take a picture of the three of us on Zoom. So, great. We now have a picture of the three of us on Zoom.
Can we see it?
It's you can see it on my screen. Oh, I'm not sharing my screen with you, am I?
Yeah.
There we go.
Okay.
All right. So in the future, we want to DeepDream this. But what we want to do right now is just make sure that we can actually run the code. So I'm going to exit camera here quickly. And from my Xcode, I'm going to run the code on my iPhone. And let's see if we can get it to work. Now, whenever I share my screen through Zoom, I don't know if it's not like optimized for Big Sur or whatever, but it gets really slow. So I'm not going to share my screen with you right now, but everybody else can see my screen. Okay, let's see. So Xcode is saying that it has run the application. All right, as you can see, it is running on my phone. I can click on pick an image. So I'm going to do that really quickly. Let's see. Okay, so it does work. It shows me a little view. I can click on cancel. You can see that animates pretty fluidly, thanks to Swift UI. And then I can click on the image that we just took. And it kind of works, except the aspect ratio is not the aspect ratio. Well, it's not the right content mode, because it's trying to show the entire image in its high resolution glory, and it's zooming into the middle part of it. So to fix that, we would just change the content mode. How exactly would we do that, though? Do we want to do fill or fit? I believe it's fit, not fill. And also, I do believe that we would want to say that the image is resizable. Like so. And we might also want to wrap this in a geometry reader so that we can measure the dimensions of the parent view, and then we can just do like dot frame geo size width and then geo size height. Okay, now I'm not completely sure if the resizable thing needs to come before or after frame and aspect ratio. I'm not even sure if it matters, but let's see. If this doesn't work, then we'll move resizable after.
Mm-hmm.
So how's the progress coming along with the backend so far?
I'm just handling the Flask right now. DeepDream is done.
Great. Labeeb, everything going well on the Flask endpoint so far?
So far, yeah, me and Omer were just trying to figure out the endpoint and everything.
Wonderful. Okay, so now that kind of messed up the layout a bit, like the buttons all the way on the top left, but it still works. And if I click on the image this time, there we go. It squeezes it into the view. Now, just because I really don't like it when an iOS app ignores the ears and the chin of the phone, what I'm going to do is just quickly say edges ignoring safe area all, and I'm also... I want the button to be centered, but I don't exactly know what I'm doing wrong in doing so. The messy way to do it, I think, maybe this is the regular way to do it, is to make an H stack and a V stack and just surround it in spacers, both horizontally and vertically. But I don't know if that's like the way Apple wants us to do it. And so I do see another comment from Hacking Pirate saying that TensorFlow models can be seamlessly integrated with Flutter by converting the model to a TensorFlow Lite model. Yes, you can do that, but then you don't get the advantages of running on Core ML. One of the many advantages of running on Core ML is that you get to access Apple's native tooling for machine learning, like for example, accessing the Apple Neural Engine. And so if you really want a great user experience, then building native is the way to go. I feel like a great example of what happens when you don't build native is Slack. Yeah, Omer, your face when I said that was particularly descriptive, and Slack.
It works sometimes.
Well, keywords sometimes, right? Slack doesn't work most of the time for things because it's running literally an entire web browser and just rendering web code on your computer.
The worst thing about Slack is that random fans spinning up so high because it's trying to render something.
And because Slack is based off of Chromium, you are literally running an entire browser to run Slack. You think it's a dedicated application, but it's not. It's a browser. So, yeah, I would say build native.
Honestly, man, soon you don't even know the difference between an app that was built for the desktop, laptop, or a tablet or your iPhone, because it's all gonna be seamless on Mac products.
Yeah, on Apple products at least.
Yeah, sorry, Apple.
So I see another question from Jason Francis. What's your take on React Native Core ML? Doesn't that run natively? Yes, it does. But then the entire problem is that you've got to code in JavaScript, right? Some people might prefer to code in JavaScript. I personally oversaw a team a little while ago that built an application for me in React Native, and it worked. It was great. But the entire issue is that at that point, you're building an application using a language that wasn't meant for the platform on which it's going to run. UI elements are great, but they don't feel at home on iOS. On Android, for example, that would be a perfect UI. There would be absolutely nothing wrong with it. Even on iOS, there's nothing wrong with it. But it just doesn't mesh with the rest of the system. That's the thing. And, like, for example, let's just say, tomorrow Apple wants to take, iOS apps and run them on Mac. That's a lot of extra overhead if you're using something like React Native, because then at that point, even if they get UIKit running on Mac and Catalyst enables you to port apps pretty easily, at that point React Native is going to be a bit of a bottleneck there, right? And so it's not going to be able to translate properly. Go ahead.
Tell me, how are you going to send me the image? In what format? So I can listen to that.
That's what I was going to ask you. How do you want me to send the image? I can send it however. I can convert.
JPEG?
How about a PNG representation?
PNG?
Yeah.
Honestly, if you just send me the bitmap, it'll be even easier. Yeah, PNG should be fine.
All right, sure. I'll send you PNG bytes, just raw bytes.
Oh, you want to send me the raw bytes? Okay.
How else would I send it?
I don't know. I have to go look it up right now.
Should I send you a base64 encoded string?
Hey, that's actually not a bad idea. I can decode that and get the image right away.
Yeah, exactly.
You want to do that?
Let's try it out. Let's try it out.
Or is that a little bit overkill?
I feel like it might be a little bit overkill, but actually...
It might be.
Oh, let's just do it.
Screw it, let's do it.
Let's do it. Okay. So everybody, as you can see, the image is now being displayed on my phone properly. Now let's take a look at actually doing the DeepDream by sending the request over. Now I could just use the Foundation networking library and do it from iOS, which, you know what, I'll just do that. I was going to install Alamofire using CocoaPods, but let's not add an entire dependency just to do a network request. Okay, so after the image has been shown, we want to check if image not equal to nil, then DeepDream, and we're going to create a DeepDream function that does this. So the DeepDream function, yeah, go ahead.
Just send me the whole binary as the image. Just make sure the context is correct. I'll just have it right there.
Fine. Well, getting the data is pretty easy, right? So I would just do let image data equals image dot png data, and just like that I've got data, and then I just need to somehow make the request. So let's see if I remember the syntax for this. URL request equals URL request. Also, yeah, I see a comment saying the screen might be frozen. I wasn't typing anything at that time, which is why it looked frozen, but now I am. Also, Aryan's asking, are you using pure TensorFlow or are we using Keras? Well, we're using Keras, but remember, with tf.keras, what ends up happening is internally things are using pure TensorFlow. And so while we are using the Keras wrapper around it, we can still use pure TensorFlow concepts like a gradient tape, which we actually do end up using. And the gradient tape enables us to actually figure out how to do DeepDream. Keras's handling of gradients is suboptimal, to say the least. The k.gradient I think function is a lot more work than it should be, I would say, and so that's why we're ironically using pure TensorFlow as an easier solution than using Keras gradients. Because if you think about it, and I feel like the reason that the complexity exists there is because Keras is meant to be simple, so when you do something like gradients, it ends up being a lot harder to do something more complex in a simple API, whereas TensorFlow is built for complexity, and so doing something a bit harder in TensorFlow is easier than doing something harder in Keras. So we're using a mixture of pure TensorFlow and Keras is what I would say. Okay, so for the URL that we're going to send the request to, I'm going to just hard code in like some random ngrok URL for now.
I'm still trying to figure out how to read a data set from like. Hopefully this is not too difficult.
How to read what?
Read an image from a request and using Python.
I think I found the link.
Huh. How exactly do you provide post data in Swift to a URL request? Okay, so it's the body. Image data, and then URL session, is it? Session. Dot. I'm forgetting how exactly you send a URL request. So let's actually figure that out. Oh, it's URL session. Yeah, URL session shared. So it's a singleton model on iOS. So URL session.share.data task with request, and then we pass it the request that we've built, and then we give it a closure, and that closure has data response error, which data response error in, and then we have our response. Now I do need to take that task and resume that task. So let's task equals this, and then task.resume. What I'm also going to do quickly is create a dispatch semaphore, like so, and then signal from within the task once it's completed, and then wait for it outside, just so that we can block the other thread until the other thread comes back. This is not recorded. I'm actually typing this live, right? So We're actually coding the same as we speak.
Mm-hmm.
Okay, so URL request is apparently a structured type, so we need to use a variable instead of a constant. Also, dispatch semaphores need an initial value to be hard-coded for some reason. I don't know why it can't just default to 0, but Swift doesn't do that, so. Okay. So in theory, I should be able to send you the request now. I'm sending you raw PNG bytes. Now, can you decode?
I'm so trying to figure that out myself. You gotta give me a few minutes.
Sure, no worries. Until then, how about we explore DeepDream more generally? There are a couple of I think pretty great examples of DeepDream that I've put together. One of the examples is of one of my friends, Ian. So we took one of his images and fed it through the DeepDream code, and this is the image that we ended up with. So of course it does modify the aspect ratio a little bit because we end up forcefully resizing to 224 by 224 because that's what the neural network is trained to output or to take as input. Now there is a separate variant of the DeepDream technique that's meant for high resolution images. But we're not implementing high res DeepDream today. We're implementing regular 224 by 224 DeepDream. So we want to be able to generate images like this. Now, what's interesting about DeepDream is that you have a lot of control over the art that you generate, in the sense that, if you choose layers that are more towards the top of the network, then you're going to get more like abstract, art like this, where there's nothing really particularly interesting. Maybe there's a little bit of edge detection going on here, where the network knows not to draw around, the person. But then if you were to draw, or if you were to use a layer that's towards the end of the network, then you get really creepy, really really psychedelic art in that case. So it really depends on where exactly you go with that network. We're getting the question, how is this different from a GAN? This is actually, I would say this is very, very different from a GAN, in the sense that a GAN is meant to generate content from scratch, right? You're taking a random input latent vector and you're trying to map it to some data that's realistic. And the way that's trained is via taking a GAN not taking a GAN, taking a generator network and taking a discriminator network and having them sort of compete with each other through gradient descent in order to solve this problem of generating realistic content. But in this technique, we're not really generating content at all. We're taking content that already exists, and we are modifying it such that we can maximize the neural network's activations at a certain layer for that input. Now, the effect that has is that we end up getting really cool art if the neural network was trained properly. But it's a fundamentally different technique and a different goal for this algorithm, I would say. Let's see if I can find another example of the code. Give me one moment.
Well, tell me, you might need to change your logic.
Will I? Well, let's see what logic we need to change. All right, just really quickly though, everybody, I do want to show you, this is what happens when you take a bit of a deeper layer in the network. Instead of getting that sort of cool abstract look that you got with the higher layer with Ian's image, when you feed in Omer and you choose a layer that's towards the end of the network, then you get things that look like this, which the neural network is really hallucinating things here, like thing on the forehead and stuff like that. So it's pretty nice art that we can generate with DeepDream. But yes.
What was that? Which layer was that? 10?
Yeah, 10. That was negative 10.
Okay,
all right,
so I need you to send me a file when you do the pulse. Can you do that?
You need me to send you a file?
Yes, I did not know you can do that, but apparently you can.
You can. I know that you can do that, but why do you need me to do that?
It'll be easier for me to process.
Okay, hold up for a second. Hold up. You can't get raw post body bytes?
I'm trying to right now. Okay, give me one moment.
Let's see. HTTP post body Flask.
No, I want to see if I can just get the data. Like, maybe my curl command to test is incorrect. Let me try again.
You could do this. Whoops. This will give you the bytes.
Let's see if it works.
Well, first of all, comment all these out. Whoops.
Okay.
Okay, now run that.
1 minute.
How many terminals do you have open here?
2.
Okay.
Let me give you access to. Okay. Let me give you access to it 1 moment. Okay, if you go to the one that I'm using at the end, you should be able to type. It should just be called bash.
All right. Yeah, I can.
So I need to double check what is the actual.
Does dash D
Oh,
send
okay.
it as the body?
Got it.
What?
It got sent.
Oh, it got sent?
Yep.
Nice. Where are you seeing that result?
If you go back to the Python one,
I just see a pip window here.
I don't see your screen, so I don't know what you're looking at,
Oh.
but it's good.
Okay.
Okay, so I'm just gonna process that and send that back. Let's see how that worked. First, I want to see if I can at least load it and then save it directly from just using image.open.
That makes sense.
Or load.
So what pillow function lets you read like raw bytes?
I'm looking at that right now.
What you could do is just stream those bytes out to a file and then read that file. Like literally all you would need to do is this. There. That should work.
No, we found it. We found a way.
Oh, you found a way? Nice.
Yeah.
All right.
It's stupid. It's literally doing what you just did,
Oh yeah?
but in a more of an elegant way.
Come on. You have to import an entire library for this?
It's okay. It's just the IO library.
Your choice.
The data is gonna be okay. Okay, we don't need to. Okay,
Okay.
let's do this.
While you okay, yeah, go ahead.
Let's do the DeepDream, like a test for it, and let's save it back and see if it works.
Okay, while you test that, let me know if it works. I'm just going to quickly say that this is the DeepDream function over here. The DeepDream function is interesting because looks like I'm following you. I don't want to follow you. One sec. What? How come your scrolling affects my scrolling? What?
I don't know.
Unfollow. There we go. Okay, good. So now I can scroll my own window. But yeah. As I was saying, this is the DeepDream function. Basically what it does is it takes a pillow image. It will go ahead and convert that image to RGB just in case it was something else like RGBA, or if it was grayscale or whatever, it'll convert it to RGB, so we have 3 color channels. And then after we have those 3 color channels, it's going to resize the image to 224 by 224. It'll convert that to a NumPy array, convert that to floating point, a 32-bit floating point, pre-process that input with the VGG16 pre-processing function. Now, the reason this is particularly important is because networks like VGG16, the way that they're trained is you actually subtract the mean and divide by the standard deviation to center on 0. If you want to learn about why that's important, I have an entire YouTube video dedicated to standardization, which I will link to in a bit. Essentially, this preprocess input function will standardize the input for us. At that point, we can just simply reshape it. This isn't really reshaping, we're just adding a single dimension to the beginning. It's called rank lifting, but we do a reshape anyway. And then I convert that to a TensorFlow tensor. Then what I do is I do 2 iterations of the DeepDream algorithm. Those 2 iterations work like this. You create a TensorFlow gradient tape, you watch the X tensor, which is the input tensor, you feed it into the model and calculate the mean, you print out the mean so you know what it is, you calculate the gradient of that mean function with respect to X, and then you run a little bit of fancy logic to figure out what parts of that gradient you want to add back to the input. This is just to make sure it's scaled properly, essentially, and this is just an epsilon to make sure we're not multiplying by 0. But essentially, what this logic is going to do for us is it's going to help us add sort of gradient-based knowledge back into the image so that we know what to add so that we activate the network as much as possible. Then we just go ahead and convert that back to NumPy, undo the standardization that Keras had done over here, clip the image from 0 to 255 so it's within 8-bit unsigned integer range, and then return that image. So DeepDream functions pretty simple right now. It does look like we're going to be done very much on time, so I feel like it would be interesting to extend this a bit more and do some more fascinating stuff after this. But we'll see. Let's finish this part first. All right, let's see. Omer, where are you at?
It works apparently. Open. Okay, I cannot just open a new file and just print it out. No such file directory. So what I'm trying to do is, there was an error trying to read with image. I want to see if I can save it and able to actually just read it, like using the built-in preview. Okay, image was saved. And of course the image cannot be translated.
Why not?
So whatever data was sent to us, it was incorrect.
Are you sending a JPEG? You're sending a JPEG. Oh wait, that wouldn't matter.
Yeah, so the URL request I'm doing is I'm doing a post. I'm posting the whole test.png, test.jpg file. And when that's getting saved, it's not saving correctly. It could be that since I'm not saving this as just a binary directly, that might mess it up, but I don't think Python really care about that. Let me see if I can do that. Python write binary. So there's a function called byte array. Maybe that will work.
Potentially.
And if that will work, then our issue with the other one will also be fixed with it.
In the meanwhile, Labeeb, I do have an interesting task for you to work on, apart from what you're doing over here in the DeepDream. Do this. You see in the init model how we have, how we're creating a model and... Oh wait, hold up one sec before we can get to that. I just realized there's a much bigger issue here. Oh god.
Which is
This is not going to be fun to work on at all. See,
why?
this is why we should not be using Python. This is why we should be using Swift.
What's the issue?
The issue
Also,
is that when we initialize the model, we're doing that in the main thread, but Flask is going to call this function in a different thread, and TensorFlow hates when you call a model from a different thread.
Oh yeah.
Synchronizing that is going to be really hard.
I was actually looking it up and I found out some people being about it in Stack Overflow.
Well, yeah, I feel like Stack Overflow is going to have to help us out here now because, ooh, this is not going to be particularly fun. Anyway, implement it and let's see what error TensorFlow throws, and based off of that, we'll fix it. But let's see what we get.
And you wanted me to work on something, I think.
Yeah, so yeah, you can start working on that while we do this. So in the init model, if you look at lines 16, 17, 18, right now what we're doing is we're getting model layers -10. So it's getting the 10th last layer. If you can, instead of just loading one model, load two models, where one of the models is -10, but the other model is like -16. And then in DeepDream, where we're calculating the mean, actually calculate the mean for both models and average them, so we can see what kind of art we get if we
Oh, okay,
average
so
cross layers.
we'll have two models, one with the 10th layer, last 10th layer, and then the other one with the last 16th layer,
Yeah.
last layer, and then we will calculate the average of both using the mean.
Yep. Exactly. So we'll calculate the mean for both and get the mean of both the means.
So Tammy,
Yeah.
screw your idea. You have to send me as a picture, like as a file. Like every example I've seen so far is send it as a file and not as the data.
Come on.
I know, it's bad. Okay, I don't like it myself.
All right. Well.
Oh, maybe I'm pretty sure my curl command is incorrect. That could also be the reason.
Well. Let's see what the -d parameter does in curl.
That should be data.
Data or body? Yeah, no, -d is incorrect. Send file bytes in body curl. It should be --data-binary, not just --data.
Okay, can you please write that up?
Yeah. So your actual command should be. It's a read-only terminal now, Omer.
I know. Let me change it back to
Come on, why is it read-only?
okay. The two we need.
Okay. There. Try that out.
Okay.
That should more than likely work.
Okay.
Yeah, so just to clear up my part, so what I understood before was like I'll create two different models, then I'll send them both with a DeepDream function, and then calculate the average mean for both.
Exactly.
Hey, we sent a picture and it got created correctly.
I told you it would work.
Okay. And TensorFlow didn't messed up.
Oh, did it not?
No, it worked.
Oh my god, that is exceptional.
Because they went to the DeepDream portion of it.
Oh,
Okay,
that is
Let me not
a
save it.
godsend.
Okay, so but there's a big caveat. We're initializing within the like process image function. So maybe it's because of that.
Oh. Yeah, that's obviously why it's working. Wait, so you're initializing the entire model every single time someone calls
No,
the endpoint?
no. Only once. Read it. If the model is not none, okay.
Oh, okay.
So let me send it a few times to see if it's messed up. Of course, I have to send you back the data. Do you want the data as a byte, or do you want just how will you like the data back?
PNG bytes.
Okay, so
Okay,
how does that
we'll
back?
figure that out in a bit. But my question for you right now is, does it work?
Yeah, I'm gonna do a few ones.
Give me an example of the DeepDream. I can't download that myself. Slack it to me so I can show everybody.
Can I just share my screen?
Sure.
I just gotta screen.
All right, Omer's
Right.
gonna share his screen now and show us the DeepDream output based off of the image that he fed in. I wonder what image you fed in.
The example you gave me.
Oh, okay,
So just one moment. Let me just minimize everything that
sure.
shouldn't be up.
In the meanwhile, if anybody has any ideas on or requests on how we want to extend this project, let me know. Also, Jason Francis, we are not using CoreML in this project, so there is no point of using CoreML here because all the computations being done on the server. One of the reasons we're not doing anything CoreML based is because we need the gradients, and calculating gradients on CoreML while possible isn't particularly fun. So,
Okay. So are you able to see?
yep, so this is the image that you used.
Yeah. So I'm gonna do the whole thing again. So these two just delete.
Oh, wow, okay, what?
Yeah. So this is the image that we're gonna be sending. So again, make sure the Python code is running. So let me just begin the Flask. Okay. So we're gonna be sending this image using data binary, and as soon as it gets sent, the model get initialized and it get processed and saved. So this is the output. So to test your theory, let's send it a few times, see if it messed up.
Alright. All I know is TensorFlow 1.15 would crash if you tried to do this.
I don't know what TensorFlow I'm using right now.
You're definitely using TensorFlow 2. There's no way you're not using TensorFlow 2.
Let's do Python. Let me
No,
double check.
run pip freeze grep python.
Look, I don't know what Python I'm using right now. I have like 10 installed on my laptop. So whatever this is going to, is I'm assuming it worked. Why do I have to do freeze? Can I just not do this?
Yeah, see, you're using TensorFlow 2.
Yeah, 2.1.
Nice. The latest is 2.3, but anyhow, you're using a pretty
Hey.
new version.
I literally just did pip install, so I don't know why I didn't get the latest one. Okay, so the last part is for you to process it. Do you want it back as I need to figure out how to send this back now.
Send it as bytes.
Can I just send you directly as what the model is returning?
Please don't. Please
Okay,
don't.
let me quickly.
Exporting that to Swift is going to be a huge pain. Literally the one thing that Swift absolutely despises. This is the one thing that Apple hates. It's the one thing they don't want you to do on their platform is bitmap images.
Really?
They do not want you handling pixels. And if you want to handle pixels, you're going to be dealing with so many undocumented APIs that you would rather not. So, it's the one thing they hate.
I mean, I had a question.
Yes.
So the DeepDream function actually does the average mean, right?
Yes.
So do I just pass the models, different models to it?
Yeah, so you're gonna use like in mean, how it has model, just calculate mean 1 and mean 2, one for each model, and then mean is equal to mean 1 plus mean 2 divided by 2, basically.
Okay, so you want to calculate two different means and then average them both.
Yeah, exactly.
Makes sense. Alright.
And the reason that I'm gonna do that, just so everybody knows, and there's actually a question about that on the live chat. The reason we're gonna do this is because when you go really deep in the network, you get different kinds of structures in the image. But when you go higher up in the network, you get different structures, right? You get more abstract art. It's like a gradient from abstract to psychedelic from the top to the bottom. And what we want to do is get some aspects of both. And if we were to average the mean across two different layers, the theory is that maybe we can achieve that. So That's why we want to do that. Now, once we actually get the data back from our URL session, then the way that I think we can just get that data back is just UI image and then pass it the data that we got, essentially. And then we can literally just do self.image equals DeepDreamed image. And that should be it from the iOS end. So yeah, in terms of iOS, I think we're doing pretty good. Now we wait for Omer to be done with actually sending back the data.
I'm looking it up, Don.
Aryan, the second model that we're using, we're still using VGG. So they're both VGG16, just different layers within the VGG16 network. So either the 10th last layer or the 16th last layer to get different aspects of both abstract and psychedelic.
Okay, so the only thing I can really find is the reply back with like the actual file, not the byte array.
Should I show you how to give the byte array?
Do you have it?
I can tell you how.
Then please go ahead and do it.
All right. Oh, wait. Actually, you might have
It's
a
right
point.
here. Right here. We haven't converted anything yet.
Okay, hold up one sec. Python read binary file to hex string. Hold up for a second. Okay, there. This has solved our entire problem.
You found it?
Yep. You just need to import bin ASCII, which I'll do for you. Did you get what we did?
Why? Why are we saving and loading and sending?
Because we don't want to convert the image directly to bytes.
Okay, do whatever you want.
Well, look. You can make it more optimal if you want. I'm not going to
No,
stop
no,
you
it's
from
okay.
doing that.
It's okay. This is the just slapping stuff together.
Well,
We're never gonna go in production with this.
yeah,
okay.
of course. We weren't planning on going to production with this anyway.
I don't know if I ever want to put this in production.
Yeah, of course you don't.
This is a proof of concept, you know.
Yep. All right, try it out.
Yay! It doesn't return.
Okay, what exactly is the issue?
Well, you never give me a response.
What do you mean I did?
No, you didn't.
What do you mean?
Well, that's technically not a response.
Why not?
Because you have to actually. So Flask have a response you have to follow.
Oh, you have to do like response dot
Something.
something.
So
Okay.
you can send files very easily, but I'm looking at how do you send a.
A string response.
Oh, you just want a string?
Yeah, because it's a hex string at this point.
Oh, okay.
Yeah, you can just return.
Yeah, you can just return.
Yeah. So then why is it throwing an internal server error? Where is Python crashing? Show me that terminal.
Aren't you on that terminal yourself?
I can't see that for some reason. Mean one is not defined. Oh, I think Labeeb's code might not
What?
contain.
Mean one is right here.
It's trying to like in the DeepDream function, I'm passing both the.
Oh yeah, sorry. Those 3 lines of code should actually be at line 67's place. So, yeah. But if you replace line 67 with those 3 lines, then you should be good to go.
Are we good?
Yep, we're good to go now.
Okay, can we remove this meme? Like, I don't want this print anymore.
No, we do, because we want to see what the
Yeah.
value is and we want to see it increasing. Alright, now if you run. connection refused.
No, that's fine. So the first time send it, I need to initialize the model. Oh, nice. We
Good.
got some. Is this base 64?
Yeah, no, it's hex. It's because it's a lot easier to decode hex in Swift than it is.
So I asked you to send me this in encoded 64, and then you just sent me the raw data. Okay, I see.
All right, so now what I'm going to do is I'm going to quickly implement a little bit of hex decoding in Swift using C.
Also, my terminal just froze.
Did it?
My whole VS Code just froze.
That's weird.
No, I mean literally VS Code froze on me.
Well, as long as the code is saved, that's all I really care about.
Postal.
Okay, so I've written a very highly optimized hex string to bytes implementation in C a little while ago, so we're going to use that.
Didn't you just say you wanna do native?
It's still native to iOS, it's just using a different language.
Why not just use pure Swift?
Because I don't want to write hex to bytes in Swift, that's just annoying.
Wait, isn't there already a library for this? Okay, so I have to close my VS Code. I will send you guys the link again.
Alright, sure.
Okay, so you guys able to see it?
Uh,
Oh, it looks like everyone's back inside. No, it's not.
Wait, I just got kicked off.
Yeah, that's fine. I'm starting a new session.
Okay.
okay, so as you can see, my iOS code should now compile. This is a very simple hex to bytes implementation. It just allocates the memory it needs to allocate, then loops through all the bytes with a stride of 2, of course, and then keeps adding the value to that buffer that it allocated, and then returns the buffer.
And you cannot do this in Swift because?
It's a lot more annoying to deal with bytes in Swift.
Oh, I see. So it's because it's unsafe.
Yeah.
Omar,
Mm-hmm.
please, I'm waiting for your host at Provo.
Oh. Tammy, please rejoin in a bit.
Sure, I will in a second.
You know, we should have just done all of this on your laptop.
Yeah, we should have. Well, I mean, my laptop is slow enough as it is right now. I don't think it needs more.
No, but what I mean is that we just copied, like, I will still do everything on my laptop, but I'll be using your file server.
That could work.
So you could technically run it locally yourself.
Well, yeah, you're right.
And see the images yourself as well, since it's on your desktop.
Yep, I could have done that, but... Oh, come on, now I can't find the function in scope. Is that because I forgot to declare it in the header? Yes, I forgot to declare it in the header. Alright, now if we build... Still failed, huh? Come on. Hex string with C string. C string. Void. Actually, no, data. Unsafe, mutable pointer, mutating. Okay, so this is basically just a bit of filler that needs to go in for the C Swift interop, and then we can just return data, hex data. Okay, let's see what errors we get this time. No exact matches in call to initializer, huh? Go figure. We could do bytes, like hex.
Oh my god, all your stuff was deleted.
Wait, what?
No, I'm kidding.
You genuinely kind of terrified me there, Omer.
About to control Z everything. Are you not running in the terminal? Because I don't see anything that you're running.
No, we're not running anything.
Oh, okay.
Okay, now my Swift code should theoretically be a decoding hex that comes back from your server.
Yeah, but where am I gonna run this code?
On your laptop.
But we don't have a connection. Do you want to set up ngrok?
Yeah, you're gonna set up ngrok. You should already have it on your machine. If you work with me, you probably have ngrok installed everywhere.
I don't remember on this laptop I have it installed.
All right, let's
No.
figure it out then. Share your screen.
I don't have ngrok installed.
Oh, you don't?
Nope.
That is.
I'll give you right access to my terminal. Just do whatever you need.
All right, sure.
First, you do need to connect to my terminal, like connect to my screen.
Sure. Yeah, I'm joining it right now.
Yeah, I don't see your.
What? Live share could not be launched.
Nice.
That is incredibly annoying. Give me a moment. Why is VS Code so annoying? We actually got a comment in the chat. Why do you use VS Code when you could use PyCharm? The issue.
I have a better one.
What?
I really don't like VS Code. I don't like PyCharm either.
Hmm.
I just use IntelliJ to have all the stuff I need to do with Python, Bash, Golang, Go, and Java, but I never touched Java for some reason. So the funny thing is I got the IntelliJ Optimal, but I don't use it for the language it was designed for. I use it for all the other plugins. There's no easy way to really share your screen, or I mean to do a collaboration and code. VS Code does that very easily, while JetBrains Suite, they haven't really got up to date yet. There are some plugins that does help, but they only last for like 45 minutes or 1 hour max for free, and then you have to pay for it.
That's annoying. Omer, I'm waiting for host approval.
Okay. So as bad as VS Code is, it's so pretty good when it comes to plugins.
I think we could use if you want to use a different one, we could use a TeamViewer software for editing and everything working on a person's computer. Because TeamViewer allows us to access the host's computer and edit any code that we want to.
But then
That's
the
not
issue.
the.
But then the issue with that though is that only one person can really work at a time, because like on Google Docs, for example, multiple people can work on the document at different portions, at the same time. We want something similar for code, but there's definitely a gap in the market for a tool like that.
Well, there's not. There are proper tools, like there are good tools that can do it, especially for IntelliJ. But
There's a gap in the market for free tools that can do that.
in the JetBrains suites.
Yeah.
Yep.
All right.
There's a new tools that they're working on that make like your life a little bit easier as a team remotely,
Mhm.
but it connected to GitHub and you need a team in GitHub. Unlike VS Code right now, anyone can just sign in and connect directly.
Makes sense. All right, give me rewrite access to your terminal, and then I'll.
Have fun.
Okay. Let's install ngrok.
You should really stop sharing your screen when you type in your credentials.
Yes, you're right. I'm not typing in credentials yet, but when I am, I will not be sharing my screen. They redesigned their website, I see. What's happening? Why can it not paste? What? I cannot paste into your terminal. Oh. Yeah, that's, there we go. Okay, so I'm gonna... What port are we running on?
5000.
What? Oh, I accidentally downloaded the Linux binary.
No, are you sure you download Linux?
Yeah. I accidentally did. No, it's the Linux. It's the Linux. It literally says stable Linux AMD 64 here, Omer.
Can you not just do brew install, Angron?
No.
Okay, you need 5000 HT to...
Oh god. Okay. So
You got your information, right?
yeah.
And you didn't share your screen, right?
Well, I mean, it's in the code anyway, so there's no point hiding it, but...
It's okay, you know, we're just gonna take my down my laptop in a couple of seconds. Yeah, someone's right about being insecure.
Alright, so... Now let's go ahead and actually call this. The endpoint is just root, it's like slash, okay. Okay. Do you think we should try it out now?
Sure.
Like, is the server running?
Oh no, you tell me.
I mean, did you run the server?
There,
Alright, there we
okay.
go.
And did someone...
What's
Wait,
happening? Why am I
wait,
falling?
what?
Line 61.
Oh, it's the with that statement was removed, I think.
Oh no, that was a good chunk of code there.
Wait, how did that get deleted? Yeah, good. That's back now. Good. Okay, so now I'm gonna pick an image.
Okay. Can you also scale your screen so we can see what you're doing?
Sure. There we go. Okay, so
Oh, so someone mentioned in the channel, TeamViewer is a very heavy software. It's gonna lag your lap computer, and the live stream will be annoying. So, to that, technically the live stream is on my lap. No, the live stream is on Tammy's laptop, while the VS Code is running on my laptop. So, I don't know if it's gonna be a lot of overhead in that scenario.
might be, I don't know. Probably not as much as it would be before.
Yeah, I remember we trying to do everything on your laptop, and it was just dying in the last example.
Yeah. Okay, so it looks like I did make a network request.
Well, I did get a network request.
And I also received some bytes.
Oh, you did? Nice.
But it doesn't show the deep dreamed image.
So what you need to do is, can we breakpoint it and
Yeah.
see what the return is?
That's what I was going to do. So we're going to breakpoint here and here and here.
Are you really checking if you have network activities?
Alright, let's try this out. Okay. So, I'm going to pick an image. You would not believe how much more fluid my system is after I just quit Slack.
Really?
Yeah.
Let me do that too. Okay, I just click Slack.
Okay, so there we go. I choose the image. We get to that semaphore. Okay, so it looks like we are sending the request. We are now waiting for the response, but I never end up
Displaying it.
like that response completion handler never ends up getting called. I feel like my semaphore might not be appropriate here because it might actually be coming back to the same thread. Let's see.
I just wanted to point out something.
Yeah.
The mean in the function, the DeepDream function, is actually the average mean that you're calculating the gradient for.
Yeah.
The one models, the mean average mean of both the models.
Yeah, exactly. And that's what we want. Because because we want to calculate the gradient for both, so we get input from both models in the final decision.
Okay, sounds good.
Okay, so we were able to send the request. Did you get a request, Omer?
I'm getting a 400 request. Did you send me something incorrect?
Wait, what?
Send
Excuse
the
me.
request again. Okay, I got a. Okay, it's good. And I post back to you.
Oh, hey, yeah,
Hello.
it got called this time. And oh, wow, okay.
Did it work?
Look at that.
Hey,
If you tilt your
If you
head,
really took it, oh my god. Wait, why? Is it so messed up?
I have no clue.
Why do you stretch it?
do you have to rotate it or something?
I do not know why it's showing us the image this way. Um, although it did work, which I'm happy about. Um, so let's try using an image that's not those dimensions. Let's search you up, Labeeb, and see what comes up. So if I just go to images, all right. So I'm gonna use your GitHub image.
Sure.
Add to photos.
You can use the second one. They look the same.
You're not wrong. It's funny, like every time we search up software names, at least this girl image shows up.
Yeah. All right. So pick an image. We're gonna pick Labeeb here. And this time there's no break. Oh, there are breakpoints. Well, we're gonna disable those so we have a bit more of a fluid. Okay, so it starts off just showing Labeeb, and eventually it gets deep dreamed.
Which. Oh,
All right.
alright. You know what? Let's do this. I'm gonna change it to a different. Wait, why do we have two models? What happened to that?
So
Rotating-
we're actually averaging the result across two models.
Oh, okay, that makes sense. Because last time we only had one, so I was a little bit confused.
Yeah. No, but we're actually using both.
Wait, so how does this? What?
Wait, what? What's happening? Where's the confusion arising?
So we have two models. I guess this is just Python because the variables are never defined, and then you just
I
take
did-
global model one, and it just worked.
In the init model, I did define them.
No, I know, but you did global model one, but you never actually say that this variable exists globally. You know
Oh.
what? Python is weird. It's just magic.
Yeah, you would be surprised that this actually works because when like in model 1 when you and model 2 when you declare these in lines 20 and 21, Python when you exit the function won't delete those from the scope. You can access them from wherever. It doesn't care.
Oh my god.
I mean, I think I did mention global model 1 and global model 2.
No, you mentioned the global portion, but you didn't actually like make the variables.
Oh, okay, true.
Yeah.
Yeah,
Okay.
Python is an enigma.
No wonder duck typing is so easy with it. I mean, just prototyping anything with it.
Yeah.
Okay, let's continue and see what's going on.
All right. So, the first thing that I want to do is actually restrict the Swift image size to 224 by 224 so we don't end up like stretching it twice.
Either way, isn't the DeepDream function really like stretching it back?
Yeah, because the DeepDream function resizes it to 224 by 224. So we'll just keep it at that resolution.
And also, can we not say the reason why Slack is really like killing your laptop is because Chrome is not optimized for ARM
Well,
on your laptop
well,
or tablet or whatever your beta is on?
yes, but why would you run an application through Chrome in the first place?
And also, you using the x86 or the ARM implementation of it?
Well, there are no ARM Macs out
Well,
yet.
you can get the little developer kit.
Yeah, but I didn't get one, and even if I did, I wouldn't be allowed to talk about it.
Oh, okay. I'm
Okay.
surprised, you know. 5 months from now, you come out, I got one.
Well, by then they would have the actual production units out. Alright, so now that we have this app loaded up, let's try this one more time. So pick an image. We choose, for example, a little zoom call.
No, that's gonna probably be messed up.
It's gonna put it in this little box, DeepDreams it, sends it back to the iOS app, and slowly but surely...
And then it crashed. No,
Did it
no,
crash? No, there we go, it worked.
Why did it tilt it?
I don't know. There's something, I will say really quickly, there's something weird about the way iOS stores images. It isn't just this project. Every project I've worked on in the past 2 years that has something to do with sending an iOS image to some other library, iOS stores position information for images really weirdly. Like in this case, Pillow was not able to determine what the orientation of the image is. Now, if I were to do it with Labeeb's image, it works and it stays right side up because the camera that took that image, or wherever the image was stored the information of what the rotation angle is supposed to be, whereas iOS just doesn't do it properly.
So if you were to take an image from Google straight up, it'll work, but since you captured it from your phone, it didn't work.
Yeah, and it's not an us problem, it's an Apple problem.
Oh, that's the first Apple problem.
Let's try something else out. Here, Kamal, okay. No, not videos, we want images. Okay, let's take one of your older images.
Oh, nice. I that full picture looked beautiful.
Okay, so we're gonna rerun the app.
Come on, do the third picture.
We only want to use ones that we have permission to use right now. Okay, so we feed in your image.
The old image.
Nice.
So position is correct once you download image, just not
Yeah.
when you take a picture.
Exactly.
Okay, what else?
Okay, so we've you know, it's actually pretty surprising we've been able to reach the objective for this live stream pretty early today.
Within 1.5 hours.
Within 1.5 hours.
So
Very
I
nice.
guess if anyone have questions, we can just start answering them, and we can look at all the answers. I mean, all the
Definitely.
questions that someone mentioned.
Definitely. In the meantime, I also do want to fiddle a little bit around with the model layers. So let's just say we go like negative like 10 or even negative
So-
6 and negative
Ca-
10.
Can we not do this? Can you not just pass us the model and then we just generate the model every single time?
Wait, what?
Can you like pass us just layer you want to do it and then we just input it? What are you doing?
I'm confused. What do you mean?
Okay, so
like
when
tell
you send
you
me
in the
that,
request which layers
Yeah.
to use. You're smart. We can definitely do that.
because this is some very this is a prototype. Let's just keep it as is.
Yeah. Just really quickly, I want to check something out. Okay, yeah, good.
Why do we care about that?
I just wanted to see if it actually reloaded. Alright. Let's try this out. So we rerun the application. Loads up on my phone. Load an image. Let's try you again, Omer.
No, I feel like every time you do me, it just look ugly.
Ooh. Give it a second. Ooh. Yeah, that's
No. I did it for something else. I was just checking something. I'll tell you after.
that is an
Oh, that's some
interesting image.
creepy. Very interesting.
I wonder if I could like.
So the one thing I don't understand, is this a video? Is this a picture? Or like, what is that thing that's happening when you hover over it?
This is QuickTime. It's doing a movie recording of my iPhone.
Oh, okay.
All right, let's take a look at some of the structures that DeepDream was able to hallucinate in a bit more detail here. Okay, that is
Wait,
interesting.
look at my mouth. What is going on?
Yeah,
Look right there in the middle.
the neural network saw something there, and it tried to hallucinate more details to really activate the neurons at that specific location.
My eyes look like they're dead. Got like bloodshot.
Well, let's go ahead and let's see what happens if we get a really large contrast. Like if we go like -6 and 16.
Okay. So you can stop and rerun it.
Yeah. Whoops. God, yeah. So now if we rerun the app, the only issue that I have when we do like a really early layer and a really late layer is that sometimes the network will just end up really increasing the activations of the first layer, and the other layer's activations are high by default because the first one was already so large, and so it doesn't really end up optimizing for the last one, but you know, it's fine. Okay, so we feed in Omer again. Okay, it's a lot less creepy.
Kind of look like I'm just having like a little bit of a blush and like my forehead just a little bit hot.
Let's take a look.
Let's do a
at
zoom in.
Yeah. That is interesting. I love how specifically the neural network was able to, you know, it's definitely hallucinating a lot on these edges, or in these places. But the fact that it's able to sort of like draw that boundary and not hallucinate all that much around the person, that is really interesting to me, and that sort of shows off the edge detection that's done by the first few layers in the network.
And like you see it, it's a lot more like natural than the previous one.
Yes, of course, because we're going in a higher layer, so it's not identifying as many like high level concepts, it's identifying more like low level edges and shapes and things like that. Now what I want to do, yeah, go ahead.
The second images always kill me when I see it.
This one.
Yeah.
Yeah. Well, that's gonna be on the internet forever now.
Okay.
All right, so now we do have a question from Aryan, and this is actually something I wanted to experiment with right now, and that is, can we try using a different model like ResNet? Let's try it out. So let's just say we use like ResNet 50, and let's only use like one of the models for this, and then we'll do the two.
Okay, let me just find out where you merged the two.
Yeah.
Okay, everything is good?
I think so.
We will know in a few minutes.
Okay, let's try it out. Oh wait, one more thing we need to do is pre-process VGG16 to ResNet 50.
Okay.
Okay. Now, let's try this out. Now after this, I do want to see what happens if we use both VGG and ResNet as two separate models.
Oh,
Okay, let's use Labeeb this time. Did it crash yet?
Yeah, I crashed.
Ooh. Okay, my app also crashed because you crashed.
Model is not callable.
Module. Let's see. Is it not called
Which
ResNet
module?
50?
Uh,
Let me
Oh,
check.
so is
Oh,
it
it's RN capital.
You know, if this was if this is a PyCharm, it'll probably tell us right away.
Yeah, of course.
So you ever say why we're not using PyCharm or PyCharm?
Because we can't collaborate in PyCharm, can we?
No. Yeah, we can. It's just 45 minutes episodes only.
Oh, yeah.
Smart one.
What now? Okay, it looks like it's not crashing. And head down the model. Okay.
So keep giving it though.
And
Oh,
it looks like
hey.
it's working.
That is, that is
That's. I think we went
interesting.
too deep.
No, ResNet is like super, super deep, so we need to go really hard in ResNet.
Okay, let's do minus like 40.
Okay, sure. Did you restart?
50 aspects of it's true.
So someone asked, is it possible to use two different models?
That's what we're going to try out next. And yes, it is possible. It just depends on what kind of result you're looking for. And wow, look at that.
What just happened?
Well, remember, ResNet is structured very differently to VGG. They are looking for very different things. And DeepDream is actually a really good way to look at how the neural network looks at the world. And in this case, ResNet seems to be looking at lots of really smaller patches to determine different like attributes of the image.
So let's do this. Let's do the two different models. See if they work out.
Sure. Have some competing
I'm using
needs.
this there. I'm assuming for the BGG.
Yeah, so we'll use ResNet and VGG.
Yeah, I'll,
Now, if we were doing this more professionally, we would actually look at which layer we're getting and not just arbitrarily do -40, right? We'd look at if we're getting like a convolutional layer or a padding layer or whatever. But right now, that doesn't really matter all that much.
we have to pre-process input for both of them then separately, right?
Yes. No, they should.
Because the one that's doing is for Resident 50, but not for VGG 60.
Hold up, 1 second. Let me check the TensorFlow Keras source code and see if they're actually two separate functions. I'm 99% sure they're just calling the same function internally.
You know, we can just literally cannot.
I was thinking of that.
Yep, they're both using the same internal function, so we only need to pre-process once.
I'll just delete this then.
Okay, so yeah, okay, you fix that up. All right, I think we can rerun this now.
Okay, let's run it. Let's see your code.
All right, let's run my code now.
Let's use the image review now.
Okay, sure.
Can we do the you as a little kid?
All right, if you want to do it.
Let's see.
Which one do you want?
Okay, let's pick the don't scroll yet. Don't scroll up. Go back to the very top. Let's flip a number from 1 to 10, and whatever that number is, we'll pick.
Okay, sure.
All right, let me ask my Google Assistant.
Generate a random number from 1 to 10. We got 4.
Okay, you and Will Smith.
All
There
right.
you go.
Me and Will Smith then. Add photos. It's pretty good resolution too.
We should have found the youngest photos of Film too, I think, on Google.
And did it crash? No, it didn't crash.
Oh,
I got a 500.
What do you mean?
I crash.
Oh, come on.
Uh,
Oh,
model
same
is not
issue. Come
callable.
on.
Model D. What is model D?
We have A and B. A is ResNet and
Okay.
B is BGG.
You didn't. Do you say yeah?
Okay, let's try this out now. Alright. Me and Will Smith, once again. Try 2. Tell me if it crashes, Omer.
It compiled with the model.
Oh, hey, that worked.
Hey, it looked better. Wow,
That actually looked
zoom
really
in
nice. I want to zoom into that.
and do a picture of me after.
Yeah. This is the first one where you've wanted to do it.
Hey, it didn't look bad. Okay.
Looks really good though.
Yeah. See, when you really experiment around with the architectures, you can get some really nice art. That's not bad at all, actually.
It looked like it avoided the face as much as possible and just do the like anything other than
Yeah.
that.
It was able to identify some important parts like IBM.
Letters, exactly.
Yeah, let's see how the other one is. Let's go to my picture or Labeeb and see how that get processed. You should really make a back button.
I actually should, yeah. Whoops, no, I fed the same image in twice. Okay, so who are we feeding in this time? Let's go Omer, and then we'll do you, Labeeb.
Oh yeah, this time will be faster since you don't have to initialize the models.
No.
Oh, come on, it just doesn't like me.
I don't know what it is. A lot of these models seem to be hallucinating something on your forehead.
Yeah. Can we pick another picture of me?
Sure.
I mean, it's actually a lot better than the one we first saw.
No, okay, that was just weird.
Omar will be having nightmares after that.
Do the first one.
Yeah, the first one's very good.
Somehow Googling
Wait,
you brings up my sister, but
yeah, I was gonna say it's nice sister.
yes,
I'm
it
like,
is.
what's going on?
It is actually. But all right.
Okay, this is funny.
Okay, that's
Okay,
not bad at all.
Yeah, it's actually pretty good. I guess it all depends how good the picture is, because this was taken from a professional camera, while the other one was taken from just a phone.
Yeah, that definitely helps, I'm sure.
Can you take a picture of yourself as a selfie and see how that works?
I could.
And let's see how the detail might affect it.
Sure.
The people probably gonna get a lot on his face.
Oh.
Hey, what happened to your upper lip?
Wait, what happened to it? Oh, yeah, that's weird. I had a mark on my top lip.
It's something interesting with the eyes, for sure.
Yeah.
Yeah, it's looking exact.
I think it all depends how the lighting is too, because his face was very bright in this picture, and I guess that kind of took a lot of detail.
This is very interesting. Okay, let's, you said a selfie picture, right?
Yes. I'm curious about a selfie of you.
Way too many apps open right now, but
I think it won't be we'll rotate the image.
yeah, it's gonna rotate the image, so we're gonna need to turn our heads around.
It's fine, it's fine. Can we not just rotate the eye time to rotate the image?
Yeah, we
Oh,
absolutely
nice.
could.
I'm curious, how is it gonna be? How is a timing selfie? If it crash, I'm just laughing.
Oh, okay.
Can we screenshot it and then rotate it?
Flip it,
and then...
yeah. Someone's asking, can we use an image where black is the main color? Sure. Because a lot of these have bright backgrounds and bright foregrounds.
Can we not just take my picture and convert the background to black?
That's much more effort than just finding an image with a black background.
Rotate. Wait, what? Okay, zoom in.
Not bad. It's good. I mean, the eyes didn't come out proper.
Wait, your glasses basically disappear.
Yeah,
Yeah,
the guys.
this is interesting to see. You can see how it,
So
found these curves over here.
I think this is a Tammy that's gonna be in his 20s with that beard.
You're actually right. It did try and hallucinate a beard here, kind of.
You see yourself 10 years from now.
Potentially, potentially.
This is a or as a predictor for future.
I feel like it tried to hallucinate something here with the light bulb too, but I can't exactly tell
Oh,
what it is.
like dark holes, something.
I don't know.
Okay, let's find a picture with just mostly black.
Where do you think we could find an image like that?
Google.
Pick one.
Person in black background. Oh, there's literally just type it on Google and you can find so much results.
Well, here we go.
Let's do it. No, this is all black. This is a grayscale. Do you want to use this one?
Well, we
I
should
was gonna
try
say,
it out.
okay. I was gonna say maybe the fourth one or something that have like some color to it.
Well, let's try it all out. I don't see why it
Okay.
wouldn't work.
Well, your laptop is not, like, heating up.
Wait, what?
Go, try it. Wait, did you not save it?
What? It's not popping up. That's weird. I guess it doesn't want to be fed into the network.
Let's do yeah, let's do this one.
Okay, there we go.
Oh, this one's gonna be interesting. It's
Definitely.
mostly all black. Should be coming back now. Oh, okay.
It became green.
It's not bad actually. This one kind of looked like it's like some effect was added on top.
Yeah, exactly.
It looked like they just put a filter on top.
Yeah,
Slap it and nothing else.
kind of. At least the face portion. The other portion looks kind of weird.
Yeah, minus that, but like it looked like it looked like they went into the void domain and just randomly take stuff out and then come back.
Yeah, it does look like that. Right, the only thing I do want to try, one more, is a picture of a dog.
We also hit in the 2 hours, like
Which,
2 hours
yeah,
time. So if anyone have questions, just post in the channel and then we'll be looking at that in a couple minutes.
definitely. Alright, let's see how DeepDream manages to convert this image.
I feel like it's gonna.
Oh,
Oh,
It's actually pretty good.
yeah, that's actually really nice.
Wait, it looked like it never even touched the dogs.
Yeah.
Can you zoom in?
I mean, it barely touched the dog. It did, but
Okay,
it
look.
didn't.
You have to zoom in for me, okay? I don't see on your iPhone, okay? I don't see those so clear quality. I get my 240 by 240 pixels. Yeah, like it slightly touched the dogs.
But it kept them mostly intact.
If it looked like they just did a blur.
I think the forest was what I messed up with. The forest in the back.
Yes, that's the part that it messed up with the most. Right, like if you take a look at the original image, take a look at what's on the back. That was so blurry that it could hallucinate pretty much anything there, and it tried its best to hallucinate tons of stuff.
Oh yeah, that's true, because this is a picture with a foreground and background that's very defined.
What I'm going to try also is increasing the number of iterations from 2 to like 6.
I mean,
Yes.
my laptop might not be able to handle that.
Well, that's what your laptop is here for. We're pushing it to its limits.
It was designed for this use case, only this use case.
All right, let's see what happens with 6 iterations on Omer. Oh,
So-
wow. That is
Wait, what?
interesting.
Wait, what? That's actually not bad.
That is actually very not bad.
It looked like it really got like some like the outline of my what the hair was.
Yeah,
I think
yeah.
there's a scar on your face on the right side or the left side.
Wait, what?
Scar on your on your face on the left side under the eye, the red,
Oh.
like red long rectangle. Looks like a scar.
Yeah.
Okay, let's do one with the dog one again. Let's see how that would work
Yeah, I
out.
was curious about that too.
What happens to your desktop?
Where?
Like, what if you did deep dreaming to your desktop?
Oh, like just the desktop. I mean, we can try that. Do you mean like the wallpaper or the actual desktop?
Like currently or not? Like the way it is.
Oh, yeah, the dog looked very messed up. You know what? You know what I noticed
What?
the whole time? I actually get the image saved on my desktop. I could just open it from my desktop.
You're right.
Well, what I wanted to
Wow.
see, like, if we take a screenshot right now of your desktop, will it read every single screenshot like that?
Let's
Letter to
let's try it out. There's only one way to find out, huh?
So what we're trying to do?
To deep dream my desktop.
Oh, okay.
All right. Let's take
Probably
that
gonna,
one.
probably gonna deep dream the dark portion even more.
Yeah. Well, remember, we're gonna take this super high resolution desktop and bring it down to 224 by 224. So,
This is not gonna be good. This is 16 no, 10 megabytes. It's gonna take a long time. Oh wait, are you reducing the size on your end?
yeah.
Oh, okay. So never
Oh,
mind.
sorry. No, it's being
Oh
reduced
my
on
God.
your end. So we're gonna send 10 megabytes of data over the network.
My dial-up internet cannot handle this.
Sorry, Omar.
You
Well,
send
let's
it?
see. Yeah, it's being sent at the moment. How's your internet holding up?
I'm kidding about the dial-up.
Well,
It's done better.
of course you don't have dial-up, but it's a figure of speech.
Look, I'm pretty sure. Oh wow, what
wow.
the hell happened? No, I have the full image. Let me show my screen.
Yeah,
Oh,
the dogs are not recognizable whatsoever. You want to share your screen, Omer?
yeah, because I got a better view of it.
Oh,
It looked like it just all messed up. What happened?
it reminds me of my Tetris game.
Yeah. No, but if you look at the image, you don't know who is who.
Yeah.
I think this is way too detailed for it.
Yeah, exactly. Especially because it's at 224 by 224. If we were to implement the high res version of DeepDream, then it might work. But
Maybe. I don't want to try it on my laptop right now for this one because we only have 5 more minutes left.
yeah, exactly. Yeah, no, DeepDream high res is like a whole different algorithm. It's not even remotely similar to the regular DeepDream.
Okay, I'm gonna stop sharing my screen.
Wonderful. But yeah, with that, we have reached the objective for today's live stream. Of course, as Omer mentioned, it would be great to now finally answer your questions. So feel
So,
free to send those in.
so the last question that someone asked, are you going to shift from ARM-based Mac when they first come out? I can answer that on Tammy's behalf because he's a very big Apple fanboy, so he'll definitely will switch. The day
I
it'll
feel-
come out, he'll go drive to some supermarket, not supermarket, some store that have it and just buy it.
Okay, maybe. Okay, well, you're on the right track, but but I will say that while I would love to switch to the new ARM-based MacBooks when they come out, I will wait for the other models they're going to release first. Because the first models they're rumored to release, at least the MacBook and the MacBook Pro, aren't particularly the models that I'm in the market for. So I will have to wait a little bit, but I do support their decision to switch to ARM. I think it's a great one, and I can't wait to see ARM being used in more technology.
He's calling you out, Omar. But
No. We have a long debate on this. We both agree ARMS itself is not gonna make Apple great. It's gonna be the Apple Silicon.
Yeah, yeah. No, the ARM, it's not about the instruction set, right?
I
I
know.
don't care if Apple made their own x86 CPU, right? What matters is the fact that Apple's making it, and the fact that they will now be able to integrate that with their other software. Good example,
So-
the Neural Engine.
Yeah. So one thing I'm very interested in is we always been seeing ARMS using like with CPU with like very low voltage requirement by wattage.
Mm-hmm.
We're going from a 5 wattage heat to something like 65. So we might see some insanely powerful like chips.
That's exactly what I'm saying. I mean, if an iPad Pro with passive cooling and battery like tablet level battery power can achieve speeds greater than, high end Intel i3s and low end Intel i5s, then I can only imagine what they would do on a Mac. But anyhow, yes, definitely would be interesting to switch to ARM. Also, yes, Aryan, we did answer your question. We did. All these last few images were done using both VGG and ResNet. Also, yes, we are doing the actual front end in Swift, but the loading and the prediction of the model is done in Python. Yeah, wonderful.
adding a back button too.
Sorry?
We're also adding a back button too.
Yeah, next time for version 2 we're gonna have a back button too.
No, and by version 2, we have this in production. You guys can just try it on your own.
Yeah, we'll have it on the App Store. But yeah, that was really interesting. So, if you do have any more questions, we still do have a minute, so feel free to put those in the chat. But thank you very much, everyone, for joining in today. I really do hope everybody enjoyed. Now, as you all probably know, this is a series that we hold. On Wednesdays in the morning Eastern time, so usually around 11 a.m. Eastern time. So if you do want to be notified whenever we're releasing this kind of content, then please do subscribe to the channel and turn on notifications. That way you actually get a notification when I'm releasing a new content or when I'm live streaming. This Sunday, if you're interested in artificial intelligence, I do recommend that you join my Tech Life Skills with Tanmay series, where we're going to be talking to a leader in open robotics. This is going to be super interesting. We're going to be hearing from an executive at AD Link. He launched the IBM IoT business unit. He's helped out with the MQTT project, that's standard. It's going to be at 11 a.m. Eastern time, August 2nd on Sunday. So make sure you do join. And with that, we would like to end today's episode. Just really quickly, I do want to say there is another question from Gunesh, who's asking, can't we do DeepDream with MLKit? I think you mean CoreML. And yes, we can. However, in CoreML, calculating gradients is difficult, if not impossible. And DeepDream requires us to calculate gradients. So while it is technically possible, it's not something that we've done right now because that would take a lot more time. So that's why we decided not to use CoreML. And also, Ramesh is asking for the code snippets. I will go ahead. I mean, we wrote all of this from scratch. This is not something we copied. The only thing we did copy is a function that undoes the standardization that Keras does. Apart from that, everything was written from scratch on the live stream, as you saw, and I will be providing you a GitHub gist in the description as well. All right, wonderful. So thank you very much, everyone, for joining in today. Thank you to Labeeb. Thank you to Omer for joining. I really appreciate it. And, of course, thank you. Goodbye, everybody.
Bye, guys.
Bye.